Hello all, good evening and welcome to today's interaction session. So let us wait a few more minutes so that others can also join the session. Good evening all. Welcome to week 9 interaction session of Nptel course Wastewater Treatment and Recycling. So today we will be discussing about the some questions and answers of week 9 Nptel lectures. So this will help you in solving the assignment questions as well as it will be helpful in other competitive exams. So these questions are taken from your previous year questions. So I hope it will be helpful for you. And if you have any doubt in between, please feel free to ask. So let us wait a few more minutes. So I guess we can start today's session. So let me share my screen. I hope the screen is visible to you.
Yes, ma'am.
Okay. So let us start the session. So before starting the session, I expect that all of you have watched the NPTEL video of week 9, and I think your assignment is due for tomorrow. So if I'm correct, so if not, please watch the video and please attempt the assignment questions as early as possible. So today's session at first let me give you a brief introduction on what you have learned on week 9. So in week 9 lectures, you would have learned about the tertiary treatment of wastewater. So you would have learned about what is the importance of giving tertiary treatment, then what are the various pollutants which are targeted in tertiary treatment, and in that in the next slides you would have learned about what is denitrification and nitrification, what is the importance of that in wastewater treatment. Then also you would have learned methods of phosphorus removal, that is mainly biological treatment methods as well as physicochemical methods. And after that you would have learned about adsorption, membrane filtration, ion exchange process, disinfection, etc. Briefly. So this was a brief overview of what you would have learned in week 9 lectures. So with the hope that you have already watched the video, let us start today's interaction session. So I'll be giving the questions first, and I'll be expecting answers from you, and there will be options, so you can spell out or say the answer loudly, because if you type in comment box I won't be able to see it, as I'm already sharing the screen of my PPT. So when I ask if you know the answer, please say the answer loudly, so that let us make it as a fun interaction session. Then we will see the answers and detailed solution of each question. So the class goes like that. So I'm explaining this all to the all newcomers of this class today. So let us start the session. And before starting the session, I am Setu Lakshmi. I am a third year PhD student. I am also a Prime Minister's Research Fellow in Environmental Science and Engineering Department, IIT Bombay. So as a part of my TA duty, I am offering you this interaction session. So this is the brief introduction. So let us start the session. So the first question is the major target contaminants during tertiary treatment of wastewater are A. Oil, grease, particles and pathogens. B. Metals, nutrients and resistant microbes. C. Suspended particles and pathogens. D. None of the above. So any guess, anyone? You can say out the answer.
It is B, ma'am.
B. Okay. Any other answer, anyone?
B,
C,
madam.
C.
C. Okay. So let us see the answer.
B.
Yes, the answer is B, metals, nutrients and resistant microbes. So in the tertiary treatment of wastewater, all those pollutants which are not targeted or which are not removed in the primary and secondary treatment of wastewater is expected to get removed in the tertiary treatment, and in that our major concern or major target or focus is on metals, nutrients and resistant microbes. If we take the case of this oil, grease, particles and pathogens, these are like, especially this oil, grease and particles, they are targeted in the primary treatment of wastewater, and the suspended particles and pathogens, they are also getting targeted on primary and secondary treatment. So the answer is B, metals, nutrients and resistant microbes. So B is the correct answer. Any doubt?
I have one question.
Yes.
It's regarding the pathogens are basically microbes.
Yes.
Uh, because after the secondary treatment, you would get some. microorganisms coming in the wastewater.
Yes, yes,
So would not pathogens or microbes be also, because we are disinfecting in the last stage?
yes, yes.
So would that not be one of the requirements of tertiary treatment?
Yes, of course, that is also a requirement. That's why we have said here that resistant microbes is also included in the category. So, all those microbes which are coming, that's a very good question. So, all those microbes which are retained in the effluent from the secondary settling tank, so those microbes are also targeted in the disinfection process in the tertiary treatment. Is it clear?
Yes, ma'am. Thank you.
Okay. So, shall we move on to next question? There is no other question. So let us see the next question. So next is a match the following type question. So there is a table given here regarding the type of treatment and also the treatment unit. That is treatment approach versus treatment unit. So you have to match first column against the second column. So, any guess, anyone? So, on the left side, you have physical, biological, and chemical treatment approaches. On the right side, you have lime precipitation method, membrane separation method, and anomox process.
Option B, madam.
Option B. Okay. Uh,
Option D.
any other answer, anyone? Okay, let us see the answer. Yes, very good. Option B is the correct answer. That is, one is matched against B. That is physical approach. That is membrane separation, which is true. Membrane separation method is a physical process in which we separate the pollutant based on their size with the help of membrane. So it is a physical approach. And we have two matched against C. Two is biological approach against Anamox process. Anamox process is a biological process. You would have learned that Anamox bacteria is capable of converting all the ammonia present in the wastewater into nitrogen gas with the help of nitrate ion present without the requirement of any organic carbon present. So that is a biological process with the help of Anamox bacteria. 2 is matched against C. And we have 3 against A, that is chemical approach for lime precipitation, which is also true, as we are taking the help of a chemical which is lime for precipitating out the all the flocculating matter present in the wastewater. Chemical approach is matched against lime precipitation. Hence, answer is B. 1 against B, 2 against C, and 3 against A. Any doubt, anyone?
Madam, NMOX process means?
Yes, Anamox process means you have this ammonium ion. So you have this, when you have this Anamox bacteria present in the system, they directly convert this ammonium ion with the help of nitrate ion into nitrogen gas. It takes place with the help of Anamox bacteria.
Okay, madam.
Yeah, this bacteria do not require any organic carbon for this conversion, and this takes place like in a in like with when all the conditions are being met or something like that. So it's a very rare process, and the like you would have learned the advantage of this process over conventional denitrification nitrification process. So if not, please go through this. This is under research nowadays, this process. So is it clear?
Okay, madam.
Yeah. I like ideally or like conventionally, the nitrogen removal is a two-step process where at first the ammonium ion it is converted to nitrates, and then then after that it is nitrate is converted to nitrates. This two-step process is called as nitrification process. After that, this nitrates, it is reduced to nitrogen gas, and this step is called denitrification process. So conventional method involves this two-step nitrification denitrification process. Nowadays we are talking about this Annamox process, where Annamox bacteria is able to convert this ammonium ion directly to nitrogen with the help of nitrate ion. So this is a biological process, since it is taking place with the help of a bacteria, or which is taking place with the help of biochemical reactions. Is it clear?
Yes, madam.
Okay. So shall we move on to next question?
Yes, ma'am.
Sure.
Yes, ma'am.
So the third question is, which of the following is a pressure driven membrane operation? A. Reverse osmosis. B. Electrodialysis. C. Membrane distillation. D. Dialysis. Any guess?
A.
A. Okay. Any other answer? Anyone?
C.
C. Okay. So any other choice? Anyone? Let us see the answer. Answer is option A, reverse osmosis. It's because reverse osmosis, as you know, it is a pressure driven membrane process based on the osmotic pressure. And other processes, electrodialysis, membrane distillation and dialysis, all these are either concentration driven or size driven processes. Hence our answer is option A, reverse osmosis. Is it clear? Any doubt?
Yes, ma'am.
No, ma'am.
Okay, so let us see the next question. So next we have, which of the following is a probable disadvantage of chemical approach for phosphorus removal? A. High sludge volume production. B. Costly operation. C. Additional treatment required for precipitate removal. D. All the above. Any lead?
D, ma'am.
D. All the above. Okay. Any other answer? Anyone?
B.
B. Costly operation.
Sorry, A, ma'am. Sorry, A.
Okay. A. Any other answer? Anyone? So let us see the answer. The answer is option D, all the above. All the three mentioned here are the disadvantage of chemical treatment for phosphorus removal. In chemical treatment, like as you all know, there are two methods which we normally employ for phosphorus removal, which is chemical treatment, that is with the help of chemical, for example lime, for precipitation, and biological treatment with the help of phosphate accumulating organisms. They are a class of bacteria. So with the help of those bacteria or by biological method, phosphorus can be removed. Also chemical method is there, where we use chemicals like lime for precipitation of phosphorus. So these three are the commonly used methods. Out of this, here we are discussing about the disadvantage of chemical treatment. So the major disadvantage of chemical treatment include high sludge volume production, because as we employ the method of precipitation, there will be lot of sludge which is getting generated, and the nature of sludge will be like that. It will be of purely chemical nature, which consists of the chemical which we are using for precipitation. Therefore the management of sludge is an issue. And second is costly operation. Of course, as we are using chemical, there will be an additional cost of chemical, the chemical needed, and also there will be other consideration like alkalinity requirement and all. So that is also a concern. The third is additional treatment required for precipitate removal. We have already discussed this, that like when the sludge is getting removed, or another headache is to remove that sludge. So that sludge removal or sludge treatment is another disadvantage. So all these three are the disadvantage of chemical approach for phosphorus removal. Hence answer is option D, all the above. Any doubt, anyone?
Yes. Ma'am, why alkalinity condition is required?
It's because in order to have the efficient method, like generally for precipitation processes, we do this jar test, where we find out the optimum pH for the most efficient precipitation. For that, if the pH is less, if for the wastewater, we need to add alkalinity to the system in order to have the optimum condition for the maximum removal for phosphorus. So that's why I said alkalinity requirement would also be a concern, or the pH maintenance would also be a concern. Is it clear?
Yes. Ma'am,
Yes.
why acid condition this reaction can occur or not?
Uh, it actually uh, it actually based on the kind of chemical which you are using. So it varies from process to process, so that needs to be looked upon. Sit, sit,
Okay, ma'am.
yeah. So any other doubt, anyone? Shall we move on to next question?
Yes, ma'am.
Yes, ma'am.
Yeah. So next is that which of the following statement about conventional nitrogen removal process is true? I think we have discussed about it before. Uh, First statement is nitrification denitrification is a biological method of nitrogen removal. Second is small volume of oxygen is required for ammonia oxidation during nitrification denitrification. Third statement is denitrification is accomplished by facultative heterotrophic bacteria. So if you have three statements, so you have to choose the right statements. So any guess, anyone?
Answer is D, ma'am.
Answer is option B or D?
D, D.
D. Okay. Any other guess, anyone?
Option C, madam.
Option C.
Option A, madam.
Option A. Okay. So let us see the answer. Answer is option D. 1 and 3 are correct. That is, nitrification denitrification is a biological method of method of nitrogen removal, which is true. I have discussed this before in the nitrification process. With the help of biochemical reaction or with the help of microbes, ammonium ion will get converted to the end product is nitrate, and in the denitrification process, denitrifying bacteria act on the nitrate ion, and nitrates will get converted to nitrogen gas. So first statement is true, and the second statement is small volume of oxygen is required for ammonia oxidation during nitrification denitrification. That's a wrong statement, because the first step is ammonium ion oxidation to nitrate and nitrate. So these are mainly carried out by the autotrophs, and the process is limited by oxygen. That is, oxygen, large amount of oxygen is needed for this step to occur. Therefore this statement is wrong. And the third statement is denitrification is accomplished by facultative heterotrophic bacteria. That is true. Though these are this process is by autotrophic bacteria. The process of denitrification is carried out by facultative. Facultative means those bacteria which can survive on both aerobic and anaerobic environment. So denitrifiers are facultative heterotrophic bacteria. Therefore the statement 3 is correct. Therefore our answer is option D. Statement 1 and 3 are true. Any doubt?
No, ma'am.
Okay. So shall we move on to next question?
Yes, ma'am.
Yes, ma'am.
Sure. So first, the next question is, first step of adsorption mechanism majorly involves the process of A. Mass transfer to adsorbent surface, B. Diffusion into adsorbent pores, C. Pore surface adsorption, D. All the above. So any guess?
All the above. D, madam.
D. Okay. The question is the first step of adsorption mechanism. So these are the three different steps of adsorption mechanism. You have to find out which is the first step. Any guess?
C, ma'am.
C. Okay. Any other answer, anyone?
A.
A. Okay. So let us see the answer. Answer is option A, mass transfer to adsorbent surface. So here we are talking about the adsorption process. So in the video in the lecture video you would have learned about the adsorption process for removing pollutant from wastewater, and there are mainly three steps involved in the adsorption process, and the first step in that is this mass transfer to adsorbent surface. This is the first and foremost step, which is followed by second step is diffusion into adsorbent pores. After mass transfer happens, the second step is diffusion, and the third step is after diffusion the pore surface adsorption is the third step. So this is the series of steps in the process of adsorption. Hence our answer is option A. Is it clear?
Yes, ma'am.
Okay, so let us see the next question. So next, the reaction is a reaction is given where ammonium plus nitrate giving N2 plus H2O. This reaction represents A. Phosphate removal reaction, B. Nitrification reaction, C. Denitrification reaction, D. Anammox reaction.
D, ma'am.
D, Anamox reaction.
D, madam, D.
Yeah, surely. I guess we all know the answer because we have discussed this before. So let us see the answer. Yes, you are correct. Option D, Anammox reaction is the answer. This I have already discussed. Ammonium ion plus nitrate ion giving nitrogen plus water. This takes place with the help of Anammox bacteria. This process is Anammox reaction. So shall we move on to next question?
Madam, this is also nitrification reaction.
No, like this is also nitrification reaction. Like this reaction is termed as Anammox reaction. Nitrification reaction, generally we say that this ammonium ion with the help of nitrifiers or nitrifying bacteria, first it will get converted to nitrite, then this nitrate will get oxidized to nitrate. So this series of reaction is usually termed as nitrification reaction. So this direct transfer from ammonium ion to N2, we call it as Anammox reaction. Is it clear?
Okay, madam.
Yeah. So shall we move on to next question?
Yes, ma'am.
Which of the following factors do not affect ion exchange process? A. Temperature, B. pH, C. Relative atmospheric humidity, D. Competitive solutes and ions.
C, ma'am.
Madam, C.
C. Okay. So any other answer, anyone? Let us see the answer. You are correct. Answer is option C, relative atmospheric humidity. So this is about what are the factors that affect the ion exchange processes. So the different factors that affect ion exchange processes are the temperature, then pH, also competitive solutes and ions. This atmospheric humidity will not affect ion exchange processes. Therefore, answer is option C. Shall we move on to next question?
Madam, temperature. How to temperature affected in ion exchange?
Okay. When we talk about temperature, the temperature is like usually this ion exchange is done like we have a resin and there will be some ion, and this will get exchanged with the pollutant or ion which is present in the wastewater. So based on the temperature of wastewater, this transfer will get affected. That's why we say the temperature affects the process, whereas this humidity in the atmosphere will not affect this process of exchange. Is it clear?
Okay, ma'am.
Ma'am,
Yes.
this process is done in open sky or closed.
It's usually done in this this type of column mainly, like where it is closed. Water will get passed through the column where this exchange resin is packed, and the process is taking place inside the column.
Okay, ma'am. Yes, clear.
Yeah. So shall we move on to next question?
Yes, ma'am. Yes, ma'am.
Yeah. Which of these is not used for the disinfection of treated wastewaters? A. Microfiltration. B.
Yeah.
Yeah. B. NaOCl. C. Chlorine gas. And D. UV radiation. So I have the option as like one of you have said A. Any other guess? Anyone?
No, madam. A option.
Okay. So A is the correct answer, because in microfiltration only the minute suspended solids which are not removed by the process of primary treatment and secondary treatment, they will be getting removed in this microfiltration. Whereas for the disinfection, we employ other methods like ultrafiltration and all. Ultrafiltration process may remove most of the pathogens or bacteria, whereas microfiltration will not remove the pathogens. Hence, option A is the correct answer. Other processes are all disinfectants or disinfection processes. Shall we move on to next question?
Yes, ma'am.
Which pretreatment process may be used to control fouling of membranes? A. Filtration. B. Chlorination. C. UV radiation. And D. All the above.
Ma'am, this is B.
D. Okay.
B.
B. Okay.
Yeah.
Ma'am, D.
D. Okay. Any other opinion? Anyone? Let us see the answer. Yes, the answer is option D. All the above. For controlling fouling of membranes, we can go for filtration, then chlorination, UV radiation. Hence, the answer is all the above, which is option D.
Madam, I have a doubt about chlorination. If chlorination giving na a chloride content will affect on membranes. It is polyamide nature na. That's why it is.
It will get affected. See, these are all like traditionally or conventionally used methods. Nowadays, as because of the disadvantage of these conventional methods, newer methods are coming up. maybe like we can go for this UV radiation, but like while talking about UV radiation over chlorination, we also have to see the cost aspect, right? We are
Madam, okay.
yeah.
But chlorination is not using in any industry.
Yeah, it might be true, but like our question is which may be used, which this chlorination can be used in order to control this problem of fouling. It can affect the membrane or cannot affect the membrane, that is there, but it will prevent the fouling of membranes, right? The growth of microbes will be terminated, right, with the chlorination.
Okay, madam.
Yeah, so the option B can also be an answer. We can always think about a newer or more effective method, but since our question is like which all methods can be used or which can prevent the fouling of membranes, hence option B can also be an answer. Therefore our answer is option D, all the above, where B is also included.
Ma'am,
Yes.
what is that formation of polyamide or he told? I was unable to understand.
Okay, so I guess who is asking this question? Can you please introduce yourself?
I am Uzair.
Okay, like someone has talked about polyamide before me. Like who was that? Can you please introduce yourself?
Madam, I am Jai Babu from Andhra Pradesh. I am working in paper industry as an environment officer.
Okay,
He,
so I guess you will be a better person who can explain this to him. So can you do that now? Can you repeat the question? Can you repeat the question? Let us see. So, as it's an interaction session, all of you are welcome to discuss. So, uh, who has asked the question?
The question asked by Mr. Uzair, and
Jai,
Mr. Uzair, right?
Ujair, madam.
Uzair, yeah. So, can you, Uzair, can you repeat the question?
Yes. So, what did he told about polyamide?
Yeah.
I don't know.
So, can you explain? Don't worry, Usair, it's not in our syllabus, but it's related to some practical problem which he is facing as an environmental officer in the real, like in his industry. So, can you explain your problem to Usair?
You tell them, madam.
No, no, no. See, I am an academic person, so more than
Okay.
me,
Mm.
yeah, more than me, you will be knowing the problem you are facing while using this polyamide membrane and chlorination, right? So, can you tell him what you are facing? So, it's like so that we all can learn. That's why I am asking you.
Okay, madam. But you know, more chlorides will affect on membrane structure,
Okay.
and means pore size increase or structure damage condition.
You're telling that chlorine will affect the polymer or polymer structure, and in effect, the polymer will get affected or damaged with the continued use of chlorine
Pore size also increase.
as an effect of damage, right?
Yes, madam.
Okay. So, Usair, he is saying that in real life, in industries, they are not going for chlorination because the chlorine can affect the polymer of membrane. Like membranes usually are made with polymers, and use of chlorine can damage the membrane. He's telling that. So, So this is a real life problem. I am not aware of it because I have no expertise in that area. So so it's a reading assignment for all of you. So can all of you please read about how different methods of disinfection can affect the polymer or the membrane, and how it can affect the treatment efficiency. So please read about that, and in the next class let us have a short discussion on that. Is it fair?
Yes, ma'am. Can I just add
Yes.
two things, ma'am?
Yes, sure.
One is when we use RO membranes, the membrane made of cellulose. So chlorine has to be removed
Okay.
before you pass it on to the RO membrane. It goes down to about 0.01 ppm. If Mr. Jay Babu can say yes, I think it's the thing. I've just forgotten the limit. So we remove it by using sodium metabisulfite. First, we disinfect. We disinfect the water with chloride, and then we remove the remaining chloride, which is in the water, by dosing it with sodium metabisulfate, and then the water is transferred to the RO membranes.
Okay.
And in the case of UV is not recommended in conditions where your TDS is high.
Okay.
I'm sorry, your
Yeah.
suspended solids are high.
TSS is high because it will
So
interfere with the process.
yeah, so these are the two things I just wanted to add.
Okay.
And thank you. Thank you for giving.
Very useful information.
Thank
Thank
you.
you for your information.
Thank you.
Or uh, one egg point is that UV is not used because of the in feed water wastewater there is a high TDS, so scaling is observed in UV lights, so that UV lamps is rapidly damaged, so that we are not using the UV.
And
Okay.
Mr. Chetan, actually, the this thing is when you use UV and if you have high suspended solids, what happens is
Before
the bacteria can be protected from the UV light. So that is why when you have high suspended solids, we do not recommend UV disinfection. That is it.
before RO feed we are using the UF membranes,
Sorry, sir.
so that already we are before feeding the RO
Yeah.
we are using the UF. UF is also to remove the TSS, lot of TSS.
Yes, sir. Agreed. Thank you.
Okay. So our discussion is getting more interesting. So I expect this kind of interaction from all of you because we all are from different backgrounds. So thank you for your valuable information or your valuable contribution, and also please note that you have a reading assignment for next class, that please read on what are the different ways in which the membrane technology can be affected with different processes, and let us have a short discussion on next class, that is Tuesday. I will also read on that. So let us have a fun session on next Tuesday. So shall we move on to the next question?
Yes, ma'am.
Okay. So next is a problem, a numerical problem. A 200 liter wastewater sample containing lead was treated with 2 gram per liter of activated carbon, which resulted in the removal of 90% of contaminant after 3 hours of contact time. Determine the original concentration of lead in wastewater sample if final concentration after treatment is 0.5 milligram per liter. So here it is said that the about 200 liter of wastewater is there, and after treatment the lead that is remaining in the wastewater is 0.5 milligram per liter, and it is said that 90% of lead is getting removed with the treatment, and here you have been asked to find out the initial concentration of lead. So it's a very simple problem, so I want all of you to do this problem, and I'll be waiting for the answer. So I shall give you about 2 minutes, 2 to 3 minutes. Please go ahead. Anyone trying?
Answer is B, ma'am.
B. Okay. Any other answer? Anyone? Okay, I shall give you 1 more minute, as I have promised. Any other answer? Anyone? It's a pretty straightforward problem. So shall we discuss the answer? Shall we discuss the answer?
Yes, ma'am.
Tell me, madam.
Yeah. So answer, you're correct. Answer is option B. Here it is said that in the effluent 0.5 milligram per liter of lead will get remained, and it is also said that the removal efficiency is 90%. Therefore this 0.5 milligram per liter will be the 10% of whatever is coming into the system, right? Suppose x milligram per liter is the initial concentration of lead which we need to find out, and 90% of it will get removed, and 10% of that will get remained in the wastewater. So 10% of x equal to this 0.5, which is this x by 10 equal to 0.5. Therefore x is equal to 0.5 into 10, which is 5 milligram per liter, which is option B. Any doubt? Is it clear? Shall we move on to next question if it's clear?
Yes, madam.
Okay, so it is just a, straight problem where you know the removal efficiency and you know the effluent concentration. Then from that you need to just find out what is the initial concentration. So the next question is based on the same information, and in the previous question, determine the quantity of activated carbon required for the lead removal process. Here it is said that 2 gram per liter is needed.
Option A, madam.
2 gram per liter of activated carbon is needed and 200 liter of water is getting treated. So it is just a straight problem where for each liter, for 1 liter 2 gram, therefore we have 200 liters to get treated. Therefore 2 gram per liter into 200 liter, which is coming as 400 gram. Option A. Option A is the correct answer. Shall we move on to next question?
Yes, madam.
Next is also a numerical. Here it is about membrane. If a membrane fed with 750 milligram per liter of TDS, which is total dissolved solids, generates 60% permeate, that is treated water, with 50 milligram per liter of TDS, what would be the TDS concentration in the reject? That is in the waste flow or concentrated flow. So all of you please work out this problem, then we will discuss the answer. I will give you 3 minutes time.
Option C, madam.
Option C. Okay. Anyone with any other choice? I think you still have some more minutes left. So let's wait. Anyone with the answer? Shall we discuss the answer? Shall we discuss the answer?
Yes, ma'am.
Okay. So answer is option B, 1800 milligram per liter. So here the information given is in the influent the TDS concentration is 750 milligram per liter, and in the effluent, which is 60% of the influent, the concentration is 50 milligram per liter, and therefore we know that 40% will be the volume of concentrate. Therefore, you can either assume the influent volume of wastewater as x liters, or you can assume it as 1 liter. It makes the same, because here we are talking about the ratio. So I am assuming it as 1 liter. Like, let 1 liter be the influent volume of wastewater, and we have 60% of it in the effluent, that is 0.6 liter is coming as effluent, and 0.4 is coming as 0.4 is going as the concentrate. So we have this equation Q1 C1 plus Q2 C2 equal to Q into C. It is just mass balance equation. Suppose this is the system we are talking about. Here you have flow, which is Q, and concentration C. It is going out into two ways, as concentrate and effluent. Here it is Q1 and C1 as effluent. Q2 is the flow rate of concentrate, and C2 is the concentration. Applying mass balance, this is the equation Q1 C1 plus Q2 C2 equal to Q into C. And we have for Q1, which we have assumed as this flow rate in the effluent. It is assumed as 0.6 liters, which is 60% of 1 liter, and the concentration is given, which is 50, plus Q2 is 0.4, and the concentration we do not know, we need to find out. Let it be X equal to, Q is assumed as 1 liters, 1 into its concentration is given, the influent concentration is 750. Therefore, while working out, we get 750 minus 0.6 into 50 is it is 30, right? Therefore, it is coming around 720. X is equal to 7200 divided by 4. It is coming as 32. 8 into 4 is 32. 1800. Hence, answer is option B. Is it clear? Any doubt?
Yes, madam.
Any doubt, anyone? Shall we?
No, madam.
Okay. Shall we move on to next question?
Yes, ma'am.
So next is also a numerical. This is the last question. Wastewater effluent having a TDS of 2000 milligram per liter and TSS of 50 milligram per liter was treated using ultrafiltration method, which produced 95% of permeate, while remaining 5% goes as the concentrate, and reduce TSS to 0, while TDS get reduced to 400 milligram per liter. Total solid removal efficiency is. So you need to find out the total solids removal efficiency of the ultrafiltration method. So all of you, please go ahead. Please work out this problem. Let us wait for another 3 minutes time. For the influent, TDS equal to 2000 milligram per liter. TSS equal to 50 milligram per liter. For the effluent, TDS is equal to 400 milligram per liter. TSS is given as 0 milligram per liter. You need to find out the efficiency of total solids removal. Anyone with the answer? Shall we discuss the answer?
Yes, madam.
Okay, so this is also a straight uh, uh, problem. The answer is option D, which is 80%. So here it is asked to find out the total removal efficiency of total solids. So for that, we need to find out what is the influent total solids. Influent total solids is TDS plus TSS in the influent, which is 2000 plus 50, 2050 milligram per liter. And in the effluent, the total solids equal to TDS concentration plus TSS concentration, which is 400 plus 0, which is 400 milligram per liter. Therefore, total solids removed equal to influent minus effluent, right? Which is coming as 2050 minus 400, 1650 milligram per liter. Therefore, removal efficiency equal to 1650 by 2050 into 100. When you work out this, it will be coming near to 80%. Therefore, answer is option D, 80%. Is it clear? Is it clear, everyone?
Yes, ma'am.
Okay. So this is all about today's session. Let us meet on next Tuesday, which is 4th of October, same time, that is Tuesday 7 to 8 p.m. As I have already mentioned, please wait, my laptop is kind of stuck. So as I have, as I have already mentioned, we will have a discussion session on our reading assignment on Tuesday. It will be a fun session where we will have a debate kind of thing, or a discussion kind of thing, where all of us will read about what are the ways in which different disinfection process can affect the membranes, and what are the type of membranes which we are using in the which we are in use now. So different, like all of us are from different backgrounds, so we will have different perspective. So it will be a fun session, I hope. So let us have that on next Tuesday for about 5 minutes. So I expect all of you present now. I think we have 5 of you here now, 6 of you are here now. So let us meet, like all of you, please join next Tuesday. We will have the fun session. I'll be noting down the names so that it will be easy. Like there is no use in asking a person who was absent today for today, like next class discussion, right? So those who are present now or today, please read about it and let us have a discussion next week. Is it fine? Is it fair?
Yes, ma'am.
Okay.
Yes.
Yes,
Okay,
ma'am.
madam.
Sure. So I hope you are enjoying the session. Let us meet next Tuesday. So that's all for today.
Yes.
Yeah. Thank you for joining and have a good night.
Thank you, ma'am. Thank you very much.
Ma'am, I have one doubt.
Yes.
That I really don't know about this numericals. I am from environmental science
Okay.
bachelor student, and I have not
Yeah.
studied this numerical, so it's very difficult for me. So can you suggest a book so that I can study this numerical?
Okay. So it's okay. Like that's why we are conducting this interaction session. So are you following whatever material which is taught here or which is taught by me?
No, ma'am.
Okay, so in that case, you have all the right to stop me in between. Okay, so from next class onwards, if you're not understanding anything, like just stop me and then I will explain to you there itself. So That is one approach. And another thing is that after the class is completed, the same numericals will be uploaded in the form of slides, and you will get the link of slides from the NBTL class link. So when you go into that, and you will find these slides, and you can work out from there. And another thing is, after each class, the professor himself is uploading lecture notes. So in that lecture notes, there will be another session called supplementary material, where some of the numericals are solved and are uploaded. So you can also take that as a reference material. Third thing. Now the fourth thing is textbook which you can follow is, as one of the standard textbook is environmental engineering by PV and Roy. So that's one of the standard textbook which you can follow for the numericals. Another other
Okay.
textbooks, one wastewater treatment and recycling by Metcalf and Eddy. It's also an international textbook which we follow. So that also you can have a look at it. So these are the textbooks. Despite of all these textbooks, another other textbooks are suggested by the professor himself, and that is uploaded in the form of, like, with the syllabus in the NBTL your class. Like, when you log into your class, NBTL class, you will find this syllabus for the course. So below that, a few textbooks are suggested. So can you go through that? Otherwise, in the next class, I will just refer it and I will tell you which all textbooks are suggested.
Yes, ma'am.
Yeah, please go through that. And also, if there is any doubt in between the class, please feel free to ask. No problem. Like, we all are in the core process of learning here. So, like, even like we all are here to learn. So please stop me in between and just ask me. Is it clear?
Yes, ma'am. Thank you so much.
So, any other doubt?
No, ma'am. Thank you very much for everything, ma'am. Thank you.
Okay, thank you. So let us meet on Tuesday.